What's up, dogs? It's Big Snoop D-O-double-G, and I'll be guiding you through the reactance of capacitors and inductors to help you gain a better understanding or to simply enhance your knowledge regarding this topic. Capacitors and inductors are electrical components used for storing energy, but the main difference is that capacitors store energy in an electric field while inductors store energy in a magnetic field. Displayed down the bottom is the equation for capacitance, which is measured in farads, and the equation for inductance, which is measured in henries. Now it's time for a quick quiz question. To increase the total capacitance in a circuit, would you connect the capacitors in series or in parallel? Pause the video and click play when you have locked in an answer. If you pick B as your answer, then well done, dog, you are correct. Those formulas show that the total capacitance in a circuit can be increased by connecting the capacitors in parallel. Moving on to reactance, which is measured in ohms, is caused by inductors or capacitors, and refers to the opposition to the flow of alternating current, or AC, that stores and releases energy. Referring to the equation for capacitors' reactance, it is evident that the reactance is inversely proportional to frequency, meaning that a greater frequency would result in a greater rate of change occurring, which then decreases the capacitor's reactance. Contrastingly, the equation for an inductor's reactance displays that it is directly proportional to frequency, which means that increasing the frequency would decrease the rate of change occurring, and therefore increase the inductor's reactance. Here we got another quick quiz question. Calculate the total reactance of a 250 millihenries coil in series with a 4.7 microfarads capacitor at a signal frequency of 450 Hz. Using the equation in the hint would give you the total reactance. And you can go back to the previous slide to obtain the equations for the capacitor's reactance and the inductor's reactance. Again, pause the video and click play when you have locked in an answer. If you calculated the total reactance to be around 632 ohms, then good job, dog, you calculated the correct answer. The first step is to substitute the frequency and the capacitance into the equation for the capacitor's reactance, resulting in 75.25 ohms. The second step is to substitute the frequency and the inductance into the equation for the inductor's reactance, which equals 706.86 ohms. The last step is to substitute these two values into the total reactance equation, resulting in 631.6 ohms. Thank you for watching Big Snoop D-O-double-G, dogs.